This video is for anyone taking an integral calculus course who wants to see solutions to exam problems explained in plain English. Find the area of the region enclosed from y equals sin² x and y equals cos² from 0 to pi over 2. I think we got this. This is a great exam question because there's a little trick in this one. You might be tempted just to set one of these as the upper function, one of them as the lower function, and then integrate from 0 to pi over 2. But let's be a little more careful. If we set these two equal, then we notice that from the Pythagorean theorem, or Pythagorean identity, we get sin² x equals cos² x equals 1/2. I want all my students to be very comfortable trying to solve something like that. Remember, sine of x is equal to cosine of x only one time in the unit circle. That's right here. That's at 45, or when theta is equal to pi over 4. So I encourage all my students to get comfortable with this unit circle and use it anytime you can. Knowing this is going to make your life a whole lot easier. Trust me. But still, we have these squares in here, so how does this relate on the unit circle? So one way to think about this is, we want to know between 0 and pi over 2, when does sin² equal cosine²? So if we look at the unit circle between 0 and pi over 2, sine and cosine are only equal at one point, that's pi over 4. And if you square these values, you get 1 over 2. So that's our value, is x is equal to pi over 4, theta is equal to pi over 4. But we were integrating from 0 to pi over 2. We just found out that they're equal halfway in between at pi over 4. So they're going to be changing there, which one's on top and which one's on bottom. I read a lot of details here about how we arrived at pi over 4. You can check that later. Now we have to determine which function's on top between 0 and pi over 4, and then from pi over 4 to pi over 2. If you like these type of explanations to exam style problems, hit like and subscribe. I'm going to give you tips like this every single day. So let's check this first boundary. Let's just plug in a point. Let's plug in 0. When we plug in 0, sin² of 0 is 0 and cos² of 0 is 1. So the top function is cosine. And then for the next one, let's plug in pi over 2, and then we get that sine is on top for that one. So we set up the integral, and notice how we have two separate integrals because the top function has changed for the second half of the boundary. For the first integral, it's super helpful to remember the double angle formula, that cos² x minus sin² x is cosine of 2x. And then we just apply negative for the second one. The rest of it is easy, just some computations here. I'm Sheldon, I have a master's in math from Waterloo. I used to grade these exams. Now I'll show you how to ace them. By the way, I've got hundreds of exam style problems like this on my site. If you feel like it, head on over.